Hello. Okay, so I haven't done a video in quite a while, so just kind of getting back into things and probably making mistakes, so that's always cool. So welcome back. And let's see. So the thing is, about 2 weeks ago, I saw this, which is on the screen here. We're not going to go into it. It's not like a reaction video here. But why a Raspberry Pi can't be a stoplight. So I actually like the guy whose channel this is on, Road Guy Rob. He's got a lot of stuff. I'm kind of like a person who's interested in roads and construction techniques and blah blah blah. And this came across my feed actually not from YouTube, it was somewhere else. And I think this other person, I don't remember his name. I will apologize. I'll put it in the comments. I'll put it in the description. Sorry, but he's done a couple of videos about how traffic lights work, and those are interesting too. And I'm sure this is just a clickbait title: why a Raspberry Pi can't be a stoplight. So it kind of irritated me a little because, first of all, they go through everything that's in the box, and then they kind of hand wave this why a Raspberry Pi can't be a stoplight because, reasons, but they don't really give a good reason for it. So okay, so let's talk about the possibility that a Raspberry Pi could be a stoplight. All right. So first, could a single Raspberry Pi be a spotlight? So let's say single consumer Raspberry Pi. And my answer to that is probably not likely, right? So here, let me do my thing here. Of course, for whatever reason, my computer is, of course, slow. that always helps. It always makes everything a lot easier. All right, so let's put this here. So here's a single Raspberry Pi. Now, let's talk about a single Raspberry Pi for a moment. I've done a lot of work with Raspberry Pis, and there's, as you can see up here, I don't know if you can see this on the screen. Oh, you can. Look at that. So up here, there's a 40-pin header. So you think you might have 40 output or input pins, and that's not true. There are a bunch of ways you can control stuff, talk to stuff, yada yada yada. But you don't have 40 functions here, right? So you can't control 40 different things from a Raspberry Pi directly. Now, there are all kinds of fancy stuff we can do with a Pi, but if there were 40 ways to turn on and off stuff, there might be a way to be able to handle stuff. But so we'll come back here and say a single Raspberry Pi, probably not impossible, but another config, maybe. All right, so what do I mean by another config? Well, let's talk about what a stoplight is, right? So I'm going to draw terribly here, but we'll draw a little. I guess we'll draw with a pencil, right? So what is a stoplight? A stoplight is, I guess we're going to draw with a box here. So I'm going to draw. Okay, I think I'm in. That's why I'm not in brushes. That's why. Okay. So, yes, I can draw. So there's three heads in a basic stoplight, right? There's one for red. Yeah, I should probably pick a bigger thing. The red for red, one for yellow. Oh, that's a terrible yellow. One for green. I should have done this as a circle, right? Okay, so there's my terrible drawing. I apologize. And basically you'll have to have a few of these, right? So what you want to do is you want to control them somehow. So what I'm going to do is I'm going to paste a couple more Raspberry Pis in there. All right, so I think we need one more. Okay, so we'll have 4 Raspberry Pis here. I don't know if you'll need all of them, but all right. So let's go ahead and select this. Take my terribly drawn thing. We'll duplicate it, so we'll have a set. Right now, we'll actually need, the way that this works is you have to have a set for each direction. So we're going to do a simple intersection here while we're doing this. All right, make this bigger. Oh, you can't see all of it. All right, I can see all of it, but what I'll do is I'll move. Oh, I can do that. All right, so that's perfect. So we're going to take, apparently I can't select that Raspberry Pi. Oh, now I can. Okay, so can I make it smaller? Kind of cool. All right. Probably should have made it smaller before. Okay. Anyways, so our first Raspberry Pi, we're going to have, we'll call it Rasp Pi 1, will be the light controller. All right. So what? Sorry. I should stop and go back. I'm sort of into the design, and I haven't kind of like given the parameters here, right? So the idea I'm thinking here is can a Raspberry Pi actually control its satellites? And maybe, but let's see. Let's pretend it's possible and kind of go through the configurations. So I have some disclaimers, of course, I should be starting with. First disclaimer is I'm not a hardcore hardware guy, right? So there may be things that I'm going to say or assume or conjecture about that are either not true, not possible, not doable. It's always possible. I'm more of a software guy than a hardware guy. I'm going to try to keep it feasible, but there may be stuff that, the hardware people will be like, oh no, you can't do it, or it can't be done that way, or whatever. So I'm going to declare that up front. The second disclaimer is that I have not professionally designed traffic lighting systems, so there may be stuff there that I get wrong, right? So the thing is that, and this isn't going to be a deep dive, I'm not going to sit there and try to put together something that will be buildable. I'm just going to sit there and be like, what if we do this and we do all this right, can we actually, have something together? So let's see. All right, so the first thing here is the light controller. So all this is going to do is it's going to take care of the lights, right? So there's 4 sets of lights here. I'm not going to number them, but can I make that guy smaller still? Make him smaller still, and we'll put him out here. So he's the light controller. The only thing that he's going to do is control the lights. Now, in this video that I was referring to, they talked a little bit about stuff that a traffic light system will do. So a basic system, all it has to do is control lights and cycle them along. So basically, you'd have red on these lights, green on these lights. If you want the traffic direction flowing these ways to slow down or stop, you sit there and you set these to yellow, right? And you set these to red, right? You wait a few seconds so that all the traffic clears the intersection, and then you turn these green, right? You kind of go back and forth between those, right? For more sophisticated intersections, you may have like left turning lights, you may have right turning lights, you may sit there and let these lanes that are going, I'll call it, upbound, northbound, whatever you want to call it, let them go through and keep everybody else stopped. You may want to do that in different areas or different ways. You may have things like pedestrian crossing signals, right? So people walking. You may have bike signals. You may have transit signals. So there's a whole bunch of complications, none of which we're going to really consider here, right? One thing that they do talk about in the video is they call traffic arriving, they call it calls, right? So I'm going to sit there, I'm going to pull a second dude here, and let's put him back, and we'll make him smaller too. And we'll have this guy as the call computer. Raspberry Pi 2. I'm a little bit lazy here, so let's do this. Actually put another line. Call controller. I like that that name call, because it reminds me of like when I did many moons ago. In university, we did some stuff when we were learning programming. One of the things we simulated an elevator system, right? And traffic lights are different, but still kind of similar. So the idea behind the call controller here is that as people arrive, what it does is it cues what should be happening next, right? So the lights go through cycles, right? So if let's say the north, south, or up, down here is green, somebody arrives here, right? It's not like the light will turn automatically just right away, right? Usually the lights, they work in cycles of 2 or 3 minutes, right? But you might not want someone to wait that long, especially if there's lots of traffic on both of these roads, both the left, right, and then the up, down road. You may not want them to wait that long. So the idea here is that a call controller, you track. So you sit there and say, oh, that car arrived. You put them in a queue. That queue then sits there and signals that, okay, well, at the end of this light cycle, we should change the lights, right? So there's a lot of complications in there. The video actually goes through them very well. I'm not going to go through them, but there's like things like you want to have the light to be green in one direction for a minimum amount of time, right? Then yellow and red, and then change it over, right? The other thing is that I think that there's usually a maximum amount of time. So the thing is, like, if something's not working, like one of your cameras is broken, because you can use cameras. A lot of rural areas use cameras because they don't want to dig up the road. A lot of urban areas, like streets in cities and stuff like that, they use induction loops, right? So induction loops are great for heavy cars or anything that are made of big chunks of metal, even a motorcycle. But something smaller like a bike may not sit there and set off your induction loop. So if something might have set off your induction loop, you still want to cycle the lights every so often so that you pick up those places where either something has failed, right? So you're not getting calls from, I don't know, maybe the second lane. Like this first lane, the camera's picking up, but the second lane's not for whatever reason. So you don't want a car to arrive there and never get a green. So you'll have like things like that. So the reason that I have these guys as two separate things, though, is because they have two different ideas and two different kind of core responsibilities. All this guy's responsibility to do is to listen to when things should change, right? And maybe take some suggestions as to what to change. But all it's there to do is basically to change the lights. Whereas this guy is sitting there and he's doing a bunch of polling and looking around and stuff like that. Now, there was another system that they talked about, which was the emergency system. Now, again, not being a traffic management expert, I have no idea what the details of the system are. I'm not gonna put that in. But what I'm gonna do is I'm gonna put the emerge controller here. All right, and I will just quickly talk about what the emerge controller does. What the emerge controller does is it allows specifically fire engines, but also, I guess, like ambulance or paramedics and police to preempt, right? So let's say there's a red in this direction and there's lots of traffic, and the police are coming this way, right? So maybe what it does is it turns all the lights red, right? So nobody can move through the intersection. The police can come in the inbound lanes, or the I guess maybe the going to the left. That's already left. Going to the left, so they'll come up this way, the wrong way up the road, come across the intersection and go the right way up this road, because those will be clear, right? It can also do stuff like if the truck has to turn left, it will turn if it's got an advanced screen for the left turning lane, will turn that on, clear out the lane so that the fire engine can come through and just turn left, and it holds everything else red. All right, so this would be something. Now, there may be more smarts that are needed for that. I'm not quite sure, but this is my kind of thought process here. So that stuff is going to handle the bulk of the logic parts. right? So let's go back and get one more Raspberry Pi here, right? So what else is there, right? So, oops, I have a Raspberry Pi 3 and a Raspberry Pi 4 here, and that's these guys. I'm going to make them smaller. Okay. I don't know if I had to do that. I can just trying to keep them proportional. I don't know if they are. Anyways, so what these guys are going to be the monitoring controllers. It's spelled out even be better. Monitoring controllers. And the idea behind these guys is that they'll supervise. Now, there's one other thing that I would put in the circuit, which will not be a Raspberry Pi, and that would be a hardware piece, right? Where if this guy fails or the power fails or whatever, what it does is it sits there and it sets them all the traffic lights to be flashing red, right? So it becomes a four-way stop, or it sets one direction to be flashing yellow. So this will be like the through direction, and this one will be flashing red. So these guys become a stop sign, and these guys have traffic going through. And that would be a hardware piece because you want that to be very, very reliable, right? Not that the Raspberry Pis aren't reliable, but none of these Raspberry Pis are super reliable, right? So one thing I will say is that I'm someone who's worked a lot with things like redundant network equipment, redundant servers, and things like that. So I know a little bit about the redundancy. They talk about some redundancy in the video. It's obviously very important that things be very robust and stuff like that. These consumer boards are pretty much the opposite of that. They're designed to be they're designed to work for a long time. I've never had a Raspberry Pi fail on me, I have to say. But like these are very harsh environments, right? They get very hot in the summertime, they get very cold in the wintertime. And the Raspberry Pi, while it's very robust and very good, it may not be perfect for those kind of environments. So the thing is that we may want to use a slight variation on the Pi rather than using Pi boards like this. One thing is that you can actually supply power in different ways here, but they're not designed for dual power supplies. And you may want dual power supplies or dual supplies of electricity to the components to make sure that they're more reliable kind of things. All right, so I can come back here in another config. Looks pretty likely. So I think that this would actually work. Oh, I didn't really talk about this monitoring controller. So the idea behind the monitoring controllers is that they're going to monitor this guy, they're going to monitor this guy, make sure that everything's working, make sure that the power and all of that is flowing properly. And if anything is wrong, it will first of all send a fault out, and second of all, it will either flip things off, like it will flip this guy off and just say, okay, just work in basic mode, or it will flip things off and put it into the hardware only mode. Okay, I think that we answered the question. I think I'm going to stop the video here, and I will see you guys next time.